So we've got a question here which is, on the face of it, really quite straightforward. It's calculating the relative formula mass of a molecule, and in questions like that all we have to do is count the atoms of each type and then use the atomic mass of one of those atoms and then essentially add them all up. This is more complicated because this is a condensation polymerisation reaction. Now in condensation polymerisation we start with n of these molecules. We start with n molecules of a molecule like this, which has 2 carboxylic acid groups, and we start with n molecules like this, which has 2 alcohol groups. And in this condensation reaction, what basically happens is we chop out a water molecule from the middle of these molecules. And so what we're left with is the molecules joined together. Now you'll notice that these molecules have 2 carboxylic acid groups. So as well as that oxygen, hydrogen dropping off, this one does as well, and that one does over there. And because we've got lots of these molecules, we end up with huge long chains of them all joined together. So the nuts and bolts of it is, if we were to draw the products of this, we just need to draw exactly the same as we've drawn here, but without the oxygen and hydrogen on the ends. So let's do carbon double bond oxygen, carbon double bond oxygen, and we're going to leave that bond open there. And we're going to leave this bond here like that, and then we're going to join it to that oxygen here. So oxygen, now we're going to draw these 2 CH2s like so, and these, and then at the end of that we join it to an oxygen, and then we leave that bond open there, and then we put brackets through it like here, and then we write on the far side plus H2O. So we have a water molecule left over at the end. So the long and short of it is, what we need to do is add up what's left, really, don't we? We're taking the water out. So what we've got here is a carbon and 2 carbons and 2 oxygens. So we've got C2O2. We've got an oxygen here, O. We've got a carbon and 2 hydrogens there. We've got carbon and 2 hydrogens there, and an oxygen. And we need to add all those up, and that's going to be the formula mass of one molecule, but then we've obviously got 3,250 of them, so we've got a few more, so we've got to multiply by that number there. Anyway, 1 carbon is 12, so 2 carbons, 24. Oxygen, 1 oxygen is 16, so 2 oxygens, 32. In fact, we've got a 3rd oxygen there, so 3 times oxygen, so 3 times 16 is 48, plus 48. Plus 2 carbons there, well, 1 carbon is 12, so 2 carbons 24, plus the 4 hydrogens plus 4, plus that last oxygen there, 16. Let's put all that together like so. That's going to be 24 plus 48 plus 24 plus 4 plus 16 equals 116. And then we obviously need to multiply that. That's 1 molecule now, 1 molecule of the polymer. We need 3,250 of them times 3,250. And we've got to do our answer to 2 significant figures. Let's just underline that there. Okay, equals. Well, I'm going to let you finish that one off. Remember, all these workbooks, if you come into these, are on ayleshamhighchemistry.com.